this career award, the title is Impact of Inlet Condition to Spray Formation. So our research will be very important for any spray applications. So one of the typical example is for combustion. So any kind of liquid fuel, you don't burn them as liquid, you would inject them into the engine, so the liquid break into small pieces. That's what we call droplets. They consist of the spray. And because the spray droplets are small, they mix with the air and vaporize efficiently. So eventually, you have the fuel vapor, the gas fuel that can burn efficiently. And if they burn efficiently, you have a better fuel efficiency, you also generate less pollution. But how to make that happen? We need to understand the mechanism behind it. We got an idea from looking at those video games. I mean, the human body is complicated, but they try to have an abstract representation, like a simplified representation, to get in only look at the skeleton, so like our bones. So I'm trying to look at the bones of these liquid structures, so a droplet will become a point, a cylinder will become a line, and a liquid sheet, complicated liquid sheet will become a sheet. So by this way, we really simplify the model so that we can use less computer resources but still capture accurate physics. So this research is mainly conducted through high-performance computing research. So we use a supercomputer here for us to do a simulation, solve the equations that govern the physics in this problem. And then we use those information to develop something we call a subgrid model or subscale model, so that people in future, they can repeat this process but without using such a powerful computer. This research grant covered about $500,000 for 5 years, so that I can support myself, support my student. We can also pay for all the computing facility that to store the data, to do the research. So our research is not to just target on one specific type of engine. We want to develop the tool that engineers can use this software to analyze any kind of fuel injection problem. So the long-term outcome of this research efforts, we're absolutely going to design a better engine, better fuel injection system that we can use all liquid fuels in a more efficient way.